Welcome to the channel. So if you're new to this channel, kindly like, subscribe and share for more. Now we are looking at hardware, which is unit 2. So we have the first question. It says hardware refers to, so hardware is or are physical components of the computer. We might have examples such as CPU, we have the RAM, we might have storage devices, we might have the keyboard. So all these are hardware devices. So hardware devices are physical components of the computer. Number 2 says which is not a hardware component. The CPU is a physical thing. It is a physical thing that is found on the circuit board, which is also known as the motherboard. So we have the CPU. This is a physical thing. Even RAM, there is a RAM chip on the circuit board. So all these are physical things. We have the storage devices such as a flash or hard drive. Those are hardware. They are physical things, except the operating system. Operating system, we might be looking at things such as Windows 10, Windows 11. These are not physical. They are software. So therefore, they are not hardware. So they are software. So the answer for this one is C. Number 3, a processor core is. So a processor core generally is a CPU unit that executes instructions, or rather tasks. So it executes instructions or tasks. I'll explain more together with number 4. Multiple core processors generally perform better. Now let me now explain both of them at the same time. So this is what we have. We have a single core here. Now here we have 4 cores. So this is an example of multiple cores. Now what do they do? Like for example, if we have this, we have a single core, meaning to say it is able to execute one task like that. Then for multiple cores, it is able to do a lot of tasks at the same time. So that's the main difference. So generally, multiple cores perform a lot of functions at the same time. Now that doesn't mean to say each and every time you have the competition between the two multiple cores are better. No, there are certain tasks that just need, let's say, one core. One core. If that's the case, that means to say a computer with multiple cores is cannot be faster than that, because it's just the task is only requiring one core. But if there are a lot of tasks that have to be done at the same time, then that means to say the multiple core computer will be better, because it's executing those tasks, or it's doing things at the same time. So now how it works is that a single core will be, let's say, if it's playing music, it will be playing music. After playing music, the instruction for playing music, it will go to let's say you're watching YouTube. It will instruct YouTube to start working after doing music. Now this is done at a very fast rate. Then at the same time, you might be playing games like that. Now for a computer with multiple cores, it will be able to execute these 3 tasks at the same time by instructing one individual core, one core to execute one task, the second core to execute one task, to produce a faster rate of action. Let's move on to our next question. It says that, which is our number 5, computer memory is responsible for. So the computer memory is responsible for this is important for holding data during processing. So the computer memory that we might be talking about is, let's say, RAM. RAM, we are looking at some background information, or rather some background apps that are being in operation. So now computer memory is very, very important. Just as you know, to say memory, just think of it as holding data during the processing stage. So the example that we might have is this. So these operations that we are running at the background, these are using the memory like that. All these like that. So it temporarily stores data and instructions currently in use. So all this is being stored like that, so that it is just stored by the CPU like that. Therefore, if there are more running applications, these require more RAM. Like for example, the device that I'm currently using is having 12 GB of RAM. That's how come there are a lot of things there, but the device is not slowing down. So that means to say more running applications require more RAM, like that. Then when we look at our 7, virtual memory uses the hard disk drive. So this is how it works. So as you saw, like that, all this is my operating at the background, but it's not making my computer to be slow. So this is RAM. Now what is virtual memory? So virtual memory is or rather involves, so as you can see, all these are running at the background, but the computer is not slowing down. So now the virtual memory comes in. Let's say if you have a small device that is having just 12 let's say 2 GB of RAM, and then you might see something like plus 4 GB when you buy a device to say plus 4 GB expandable. So what is this 4 GB expandable? So a RAM is very small. You can think of it as a compartment like that. It is storing data that is being executed like that. Now there happens a time whereby, let's say your computer is 2 GB of the physical RAM plus 4 GB of expandable RAM. So what this means is that, let's say you install a game that requires 5 GB for it to work. That means to say you have the hard drive, which is bigger in size. So from the hard drive you have this expandable RAM, which is your 4 GB like that. Okay, let's say this is the 4 GB from the hard drive. Now this memory, which is the virtual RAM, it's not in this small RAM box like that, but it is in this bigger hard disk. So therefore this RAM, you will be able to access this game that requires 5 GB by using the 2 GB from RAM plus the 3 GB from the external like that. By using that amount of data, you are able to play that game that you require. So this virtual RAM is stored in the what's this? It is stored in the hard disk space. So now, when this is frequently used, it makes the computer to be slow, because it is very difficult for you to get information from the bigger thing like that. Let's say the information is here. The computer has to move. Let's say it's coming from here. It has to move, look for the information, and collect that information, then display. But RAM is small, so therefore you can just get find the information, the computer is able to display it like that. So that is the operation. When we look at number 8, a swapping file is a temporarily stored file. Swapping file is sometimes called a paging file. So this is an example of an application of the virtual RAM. So this is temporarily file on a storage. Like for example, the same thing whereby if the RAM runs out, you store some data in the hard disk, which is mostly slow. You store some data in the hard disk. So this is done temporarily so that you can be able to access certain information or run certain applications. So this swapping a file or paging a file is an application of the virtual RAM like that. Moving on to our 9th question, it says that virtual RAM may. So the virtual RAM, just as I have said, it is able to decrease performance because you have a bigger space which you require to access data, of which it will take time to look for that data. But if it is in RAM, which is the smaller RAM, you can just be able to gain access to that information. When we look at our 10th question, it says that RAM is So RAM is volatile, meaning to say it is it disappears whenever a device is switched off. So when we switch off, you will find that RAM disappears, the things that were running in temporary memory, because RAM is temporary. So it's volatile, meaning to say it loses its content when power source is cut. Now ROM, on the other hand, is permanent. So ROM, I'll explain more when we look at. So ROM, the example that we might have, ROM stores what we call firmware. So firmware, we might have examples such as the BIOS, which are temporary, which are permanently stored in form of RAM. So BIOS, which is the basic input-output system, this one, it enables the computer to be able to, more like the computer, when let's say you switch it off, you switch it on, how does it know how to switch on? So that is a permanent thing. That is an example of the application of ROM. So it helps in the switching on process, switching off process. It is permanently stored as firmware in form of BIOS, basic input-output system. Number 12 says the motherboard contains. So the motherboard is also known as the circuit board. So the motherboard is made up. So this is the motherboard. So the motherboard has got different form factors. So form factor is just the shape and the size, as you can see there. So it is just the shape and the size. Now this is made up of the CPU. So as you can see, this is where everything is. So where you can think of the memory and the CPU, it is found here. So it is the CPU that the motherboard is made up of the CPU and memory, such as RAM, among other things. So we might have different things, the memory, we might have the graphics processing unit. So anything that has to do with the CPU as well as the memory, it is put or stored on the motherboard like that. So it is the circuit board where it connects all the components and allows communication. So as you can see here, we have the CPU, we have also the memories. So for example, these are memory like that. We have an heat sink which dissipates, or rather it releases heat like that. So our CPU contains the motherboard, contains the CPU and memory. Then when we look at BIOS, remember BIOS, I talked about it, which is a ROM, basic input-output system. This is important in the storing of permanent instructions that cause the computer to more like switch on. How does it switch on? How does it know? So that is permanently stored in ROM. Firmware refers to, remember what I said, so firmware is simply the permanent instructions stored in ROM, or rather permanent instructions in ROM. So these instructions, the powerful example was, how does the computer know how to turn on? Then when we look at our 15, it simply means we have DRAM must be, so DRAM must be constantly refreshed. So that means to say, if we have DRAM there, for you to be able to gain some information, it constantly has to be fed with power, electricity, and all that. So therefore, it is relatively slower as compared to static RAM. So static RAM is faster but more expensive, because of the fact that it does not constantly have to be refreshed in order for you to have data. But for this one, when charge builds up, it is easily able to lose the charge, which is the DRAM. Then you have to apply another charge to maintain certain information. So all these are RAM. Remember, it's memory stored like that, and this memory, for it to be accessed, it frequently has to be fed with power. That is for the DRAM. but for the SRAM, it is not frequently fed with power, or rather it is not constantly refreshed. Therefore, it makes it faster, as it is able to store the information as a 1 or a 0 permanently, like that. But therefore, even SRAM is used in making things such as cache memory. As you know, if you download an app such as WhatsApp, maybe it might be 27 MB, but with time you will find that it has increased. So these are some of the contributions. So when we look at the cache, it is used to store frequently used data, like that, frequently used or accessed data, so as to reduce access time. So the SRAM, which is the static random access memory, DRAM is dynamic random access memory, which is faster but more expensive. When we look at our MRAM is a type of RAM that is magnetic resistive. It is magnetic based RAM. So MRAM, we have magneto resistive RAM. So this is magnetic based. It uses magnets in order for it to more like access information. It is not volatile. So it is not volatile, meaning to say it does not lose information when it is switched off, like that. So that's that. So this one sits, if we have DRAM in terms of speed, we are going to have then MRAM, then we are going to have our SRAM, which is static random access memory. Dynamic RAM, just think of dynamic, meaning to say it's changing, so it has to be constantly refreshed. We have the SRAM. So this is the order of speed. The MRAM is very fast. It is almost as fast as the SRAM in terms of access time. Remember, this is memory, so it influences how fast you're able to get certain information. So that is the three in terms of the speed. So this one has got the performance, more like it has got the performance similar to SRAM, it has got the performance similar to DRAM, so it's in between, like that. It uses it is magnetic based type of memory, which is also RAM in that regard. Then when we look at our 18, it says flash memory is, so it is non-volatile. It is non-volatile, meaning to say it does not lose its contents whenever power is lost. So flash memory is used in USB drives, which you call flash drives. So those flash drives, when let's say you remove, or maybe it's on a TV, then electricity goes. When electricity comes back, when you put it there, the same movies that are there, you are going to find them. So it is non-volatile, meaning to say it does not lose its contents whenever power goes. So it retains its data without power and is used in USBs and SSDs, so which is the solid state drives. When we look at our 19, a platform refers to, so a platform, just as the word entails, a platform simply refers to an operating environment. So this operating environment, like for example, if you're looking at Microsoft Word, the platform on which Microsoft Word works is, we might be talking about, let's say, Windows. We might be talking about things such as Mac OS, like that. So these provide a platform for the Microsoft Word to work. So Microsoft Word can work on Windows, it can work on Mac OS, which are types of operating systems. Then we can also be looking at, let's say if we look at a mobile a mobile game. A mobile game, these are just games that you can play on the phone. These games can work on, let's say, the Android, or it can work on iOS, which is the iPhone. We have a lot of examples that you might think of. So a platform is simply operating environment, the operating environment on which a program can run. So these or a platform can either be a hardware, it can be a hardware or a software environment. So it can be a hardware or a software environment on which programs can run. So the answer for that one, it is an operating environment on which programs can be able to run, like that. Then when we look at our number 20, remember what I said about the motherboard. We have the size and shape is just what we call a form factor. So the size and what shape does it have is what we call a form factor. So form factor means we are just looking at the size and the shape. Then when we look at our 21, desktop computers are, so the desktop computers are stationary. That's why they are called desktop, because they are mostly fixed on, let's say, just one disk like that. That's why it's called the desktop computer. So they are stationary. When we look at our 22, we have all-in-one computers combined. So this is an example of an all-in-one computer. So an all-in-one computer looks like something like this. So as you can see, this one is ultra thin. It's very, very thin. So this one combines what we call the system unit and the monitor. So it is all-in-one computer. Computers are made in this way so as to save space. You don't look at computers that look, let's say the behind is something like this. No, but you will find that the computer itself, it will just be maybe this thickness. It combines the monitor and everything is there, which is the system unit, the central processing unit, in just this flat sized thing like that. So an all-in-one computer is a computer that combines both the system unit and the system unit. We might be talking about the CPU and all that, and also it combines it with the monitor like that. So this is generally the monitor, which is made up of the screen and even the external part here. So that is what an all-in-one computer is. So for this one, we have the monitor and the system unit. Laptops are compact devices. They are portable compact devices. This word compact simply means to say they are small, they are lightweight, which means to say they are easy to carry. When we look at our 24, ultra thin laptops are, so ultra thin, ultra, which means very extremely, thin means small, so extremely small laptops are, they are lightweight. So this is the only option that matches. Ultra thin meaning to say they are extremely thin, they are lightweight. Then when we look at our slate tablets, these slate tablets have no keyboard. So when we look at our slate tablets, they have no keyboard. Convertible tablets, these are the ones that have detachable keyboards. Like for example, if you have the tablets there, then you have more like a keyboard like that. So keyboard, buttons, A, B, C, and all that. So these can be able to be connected in such a way that you can be able to connect them in that way. So you are able to connect them to form a laptop. It's either you can connect them or you can be able to detach them. So by doing so, to make into a iPad. So this is your iPad here. it is able to more like accommodate a keyboard like that. It's convertible because it has got a detachable keyboard, meaning to say you can remove the keyboard in that manner. So that is what we simply mean when we say that it's a detachable, or rather it is a convertible keyboard. It can operate as if it's a laptop, or it can operate as if it is a tablet like that. So that is what we mean by that. When we look at our 27, a scanner is an example of an input device. So just as the word entails, it scans. So it is an input device. It is able to convert physical documents like what you see, documents into what you call digital form. Like for example, if you get, let's say, a paper, like that, then this paper, there are words where the boy is cooking. If you have this, then if you scan through, what happens is that when you scan like that, you will find that these words that are on paper will be able to be converted into a form, a digital form on, let's say, your phone or your PC like that. So that is a scanner. That's how it operates. Number 28, a printer produces, this is very, very simple. A printer produces hard copies. So it produces hard copies like on paper, what you can see or what you can see, which are the tangible forms of what you can see on paper. So it is able to produce that. Number 29, inkjet printers use, just as the name entails, inkjet printers use ink. So this type of a print operates by adding some drops of ink on paper, then it will be able to run through the paper until scanning is done like that. You can just think of those drops as helping to identify the letters by adding more ink like that. Then when we look at the laser printers, these use, so we have the toner and laser. So just as the name entails, it also uses toner. So this is what you might think about. So already a laser, we are here, a laser is a beam of light. So when the beam of light comes there, let's say we have a paper there, it strikes there, then toner, you can just think of it as not even to say toner is a powder. So this is more like powdered ink. Whenever light strikes there, it attracts the toner to be on that paper. When it is on that paper, then we have what we are going to have, a heat or fusor melts. So meaning to say the toner is now melted so that it can be more like in a bit of liquid form and stay on that paper. Now what happens is that this is more like dried ink. So this dried ink, when it dries there, it is able to paint parts of the paper like that. On one part it might paint the color red, on another part it might paint the color yellow to the color blue to produce an image like that. So all this just depends on the image requirement and all that. So it uses what we call toner, which is a fine powder, and a laser. When we look at our 3D printers create, so unlike these other printers which create things on paper, when we are looking at our 3D printers, these actually create actual objects which can be modeled, which you can physically touch. So these create physical images, or not images, physical objects which you can touch like that. So that is the operation of the 3D printers like that. So they create 3D images such as let's say this, not on paper like these other printers. Let's look at our 32. Voice synthesizer converts. So to synthesize is simply to make. so it converts, so it's a voice synthesizer, so meaning to say it's a voice maker. This one makes a text into speech. So we have text into speech. Let's move on to our 33. 33 says projectors display. So projectors display output, meaning to say what we can see. So they display images onto a large surface. So if you have a projector here, it is able to more like project, or rather display images on a surface to produce whatever is required to be displayed like that. So that is the working principle of a projector. It is an output device because it shows you what you are able to see on a surface like that. So a projector is output. Then we have plug and play devices. So just as the name entails, plug and play, these immediately work. Like for example, if you have the computer like that, plug and play, let's say you have the computer, you have you have the computer, then you connect your flash drive. So as you connect the flash drive, immediately it starts to work there and then. So that plug and play devices are those devices that starts to work automatically when connected to the computer. So immediately you connect them, they start to work immediately. Then when we have device drivers, so device drivers, those are devices that allow communication. So communication between the operating system and the device that you are interested in. So that is the device drivers. So device drivers are, so the example that we might have is a printer driver. So a printer driver, so what it does is that it converts the document. Let's say you put the document on a printer, it converts the document into a format that the printer can be able to understand. So without the printer driver, it cannot be able to print. So that's why it controls, or rather helps in the communication of the operating system and the device of interest. So therefore it acts as a translator. So this is its function is that it acts as a software controlling device. So without its translations, there could be no action. Then when we look at the number 36, clock speed measures. So clock speed simply measures what we call the processing speed, which is just the number of cycles that have been made per second. So the number of cycles per second is what we call clock speed. So the clock speed is measured in units called the gigahertz, which is indicating how many cycles per second the CPU performs. In other words, this is the number of instructions that the computer can be able to execute or perform in a given second. Others might be 1 gigahertz. That means to say it is able to process instructions that are giga is 10 to the power 9, which is 1 billion. So it is able to produce about 1 billion number of instructions in a given second. So that is what we call clock speed, which is the processing speed. Number 36, a cycle is, so a cycle is just the smallest unit of time. When we look at our next one, it says instructions per cycle. Instructions per cycle measures efficiency. So instruction per cycle is the number of instructions that a CPU can execute in one cycle. How many instructions? So this is where the 9 to the power that comes in. How many instructions is it able to execute within the smallest amount of time, or rather within one cycle? How many instructions is it able to execute or perform? 39. bus width determines determines the data speed, the rate at which data is transferred. So bus width, we might have 8 bits, meaning to say 8 bits of data can be transferred at once. Let's say if we have 8 lines like that, 8 of them can be transferred at once like that. That is what we call bus width. That means to say if you have, let's say, 64 bits but bus width, let's think of it as having 64 like that. It means to say 64 bits of data can be transferred at once like that. Then also just think of it as cars. Let's say if you have one lane like that, you have this number of cars. For them to reach where they are going in this direction, it will take a lot of time for that car and there will be traffic. But however, if we have a lot of lanes like that, these cars will reach in the smallest amount of time. So the bus width determines the speed at which data is transferred between the computer components. So these components, how much faster is data able to be sent to another component? That is the bus width. Then our 40 is benchmark is. So a benchmark is simply a performance test. How does one computer perform in comparison to the other is what we call a benchmark. So under the benchmark, you're going to check the performance of certain things such as how is the RAM operating. You might also be looking at how is the CPU speed, how are the graphics in comparison with one computer and the next. So under this one, you might find that computer A might score something like a 3000, a score of 3000, then computer B maybe scores about 200. That means 2000. That means to say computer A is better than computer B. If you compare the graphics, the RAM, the CPU speed, and all that, that is a benchmark. So it is just a test for or rather it is a performance test. So we use the benchmark to test for upgrades and also identify slow components. So that is the benchmark. So we are on 41 now. So we are moving from 41 until 80. So UPS is simply what we refer to as backup power. So UPS simply means uninterrupted power supply. So interrupted you there. So we have an interrupted power supply. This one provides backup power so as to prevent very important information from being lost in case of a power outage. So immediately, let's say power is cut, it's not immediate that it switches off. So this uninterrupted power supply is very, very important. Then when we look at our surge suppressor, this one protects from voltage spikes. So when there is a lot of voltage, let's say if we have the computer cable like that, this is just an example to make you understand. We have a lot of voltage coming in at once. The charge suppressor protects from such voltage spikes. So what it does is that it either sends the excess voltage into the ground so as to prevent devices connected from being destroyed, or it can absorb that charge depending on the charge and the outcome to prevent the damage of those devices. Then when we look at blackout, what does blackout mean? So for the charge, so for the blackout simply means to say there is no power. So a blackout is a situation where there is no power like that. The example that we might have is a power outage in a city, you just see the whole town, electricity has gone at once. That is a blackout. Then when we look at a blown out, so blown out, we are just looking at where there is a voltage drop. So when there is a voltage drop, then that means to say there is a blown out. So you might find that even the bulb starts to light up dim and all that. That means to say there is a blown out, there is a reduction or a drop in the voltage like that. Our 45 is spike is, so you even know how a spike looks. It looks like a thorn like that. So a spike is just a sudden increase. So we have a long increase. So a sudden increase, it could be in voltage or anything. That is a spike. Data backup protects against. So under this one we have the data loss. So to prevent data loss, there should be a data backup. It protects data loss. If you are backing up data, it means to say you are keeping it in something that is separate, so that in case where you put the data, it gets let's say destroyed, you have something like this, it gets destroyed like that, you can still retrieve your data. So that is data backup. So it protects from data loss. When we have our wireless router connects, so the wireless router connects networks. So you might have a local area network whereby you have computers connected like that. Then these computers, for them to be connected to the internet, which is the globe, so I might just draw a sky like that. For them already, this is a wide area network. The internet is a wide area network. That means to say for you to connect from a local area network, these computers, for them to get the information from the internet, they need a router. So the router will be able to connect networks. We have the local area network there. This is the local area network with a network such as the wide area network. Wide area network, you need a router for that. Then we have the HDD stores data. So the HDD stores data using what we call magnetic disks, which are made of moving parts. So as the parts move and rotate, then you can have data being read or written like that. So HDD stores data, which is the hard disk drive. It stores data magnetically using magnets like that. Then SSD is generally, it is faster, it is not made up of moving parts. So that's SSD. So this one uses what we call the flash type of memory. So we have flash memory. It is not made up of moving parts, it's static. That's why it's a static state drive. Then when we look at our 50 optic media uses, so let's define two different terms, which are writing and reading. What is the difference? So reading has to do with let's begin with reading under the computer. So we have reading is you getting, let's say something is in the hard drive, you have a book like that, you press on the book, you open, that is what we call reading. Then writing is you saving or storing data to the storage. Like for example, let's say you are using Google Drive. Google Drive can be used, you are typing something, you write an essay like that. Because you are writing, that means to say when you save that information to the hard drive, that means to say in your internal space, that means to say you are writing. But for you, let's say you have a document such as a book, you have a book such as a mathematics book, which you got from somewhere. Then this book, you press on it, Immediately you press on it, it reveals the content that is there. That is what we call reading. So reading, you are not changing anything, you are just getting that information. You want it to be displayed, let's say on the computer. That is reading. Writing, on the other hand, is you more like making edits, then you save it to the hard drive. Now because you were adding some things, that means to say you are writing. So that's the meaning of those two terms. Then when we look at this one, optical media uses. So optics has to do with light, and the only light here is a laser. A laser is a beam, a laser beam, which is like a beam of light which is used to read and write data. So if you want to read or write data, you use that's the function of the optic media. So it uses a laser to read and write. So remember, to read simply means to say you are opening something without making any changes, while to write you are making changes in that regard. Number 51, network allows. So networking allows the sharing of resources. Like for example, you are able to share files through the network, you are able to share messages, and also you have the internet. So that is networking. And you can also share printers. This is the same idea, whereby we could have, let's say, 4 computers, we have 1 printer. These computers can share 1 printer. You want to print out the word there here, this printer is able to print out here. If you want to print out the number 23, it is able to print out. So you can be able to share resources via the use of a network. Number 52, what is a node? So a node is any device that is connected. So that is what we call a node. So a device on connection. It might be a computer, it might be a smartphone, as long as it is connected to a network. That is what we call a node. Number 53, which is our hub, sends data to all the devices. So if you watched the other video, we talked about the hub. So the hub is this one. So this is the connection of the computer. So let's say if you send a signal here, this whatever message you send, it shall be directed to all parts. So that is a hub. You send here, it goes like that. So that's the hub. So a hub sends data to all. Then when we look at a switch, sends to specified devices. That's why it's preferred. Like for example, if you have this type of an arrangement, they might look similar, but a bit different. So if let's say this is the switch now, this time it's a switch, you send a signal, you send this signal and you want this signal to go this side. That means to say this is the only thing that is going to see the message. Like for example, you send from this PC hello, you want someone on this PC, or rather the computer, to see, it will be shown like that. That is the switch. But for the hub, at all points they will be able to see the hello. Even the private conversations will be seen like that. That is the difference. So the hub or the switch sends to specified users. The router connects networks, which we have talked about. So it connects the networks. Number 53, modem connects the internet. So I have explained further on the modem. So like for example, if we have the modem there, we have the internet like that. The internet sends signals which might be analog. Then the modem, because the computer can only understand ones and zeros, this signal will be converted into the digital signal which the computer can be able to understand. So it modulates and demodulates. I have explained further in unit 6 how this is done. Then when we look at 57, we have NIC allows. So the NIC allows what we call the network connection. So NIC means network interface card. So the network interface card, which is the NIC, allows for there to be a network connection. So this uses what we call a cable such as an Ethernet. Ethernet is just a physical cable. We can have an Ethernet, or we can have wireless, such as the use of Wi-Fi. So NIC, which is the network interface card, allows there to be a network connection. You can use an Ethernet cable which can be connected so that you can share the network. Then DSL uses, so I've explained some of these questions in another video, telephone lines. So the telephone lines, we might have those land phones. These will use to form the network. We have the telephone line like that. We have the DSL decoder there. So I've explained this further in Unit 6 with proper diagrams. Then let's look at 59. Heat sink. So the heat sink, it's a heat and it's a sink, and the sink removes stuff. So it dissipates heat. So to dissipate simply means to remove. So it removes heat to prevent overheating. So it removes heat from the system in order to prevent overheating. So that's the function of the heat sink. Then we have the cooling pad is used for, just as the name entails, it cools laptops. So a cooling pad just cools laptops by improving the airflow under the laptop. So if you have the laptop, if more air is flowing, then that means to say there should be a reduction in heat. So that is a cooling pad. Then when we have a computer chip is made of, so a computer chip is made up of what we call a silicon chip. So it is made up of silicon, which is a semiconductor material. So it is a semiconductor material. Silicon is a semiconductor material that is used to make computer chips. So these chips are used in making RAM, making ROM, which we have discussed what these do. So we have our 62 integrated circuit contains. So this integrated circuit contains what we call pathways. So these pathways are more like the passages which the network can be able to pass. So it is a tiny electronic circuit etched onto a chip. So onto a chip, there are a lot of pathways that are there. So that is what an integrated circuit is. So integrated simply means to say it is made of more like different, I would say different paths. So an integrated circuit contains different pathways like that. Then when we have 63, fetching means, so when you fetch something, you are grabbing it, bringing it to where you are. So if you are here, you are getting it and bringing it to where you are. So fetching involves getting instructions. Then decoding means, so to decode simply means to say you fetch after you fetch something, you decode it, meaning to say you translate the meaning of that thing. So upon arrival, you decode, it means to say you translate. You translate meaning to say you give the meaning of something or understand the meaning through translation of that thing. When we look at our next one, which is our 60, where's 65? So 65, was that 64? 65 says executing means, for this one, which is very, very simple, executing simply just performing instructions. So you doing something, that is executing. So remember, we have fetching, which is you grabbing instructions, decoding, translating or knowing the meaning. Then executing simply means to say you are able to now perform instructions. So performing instructions, I want to wrap that. Performing instructions is what we call execution. Then we have storing in CPU means. So this one is writing to memory. So get the difference. Reading is you getting data from memory. If you're getting data from memory, that is reading. Then writing is you storing in CPU. That means to say after you process everything, you execute and all that, you make some changes. That is now you writing to memory because you have changed the data that you received. Number 67, registers are, these are just high speed. What is the question? Well, registers are high speed memories in CPU, so they are very, very fast. They are found within the CPU itself. So those are registers, which in another video explain more on registers. The RSI affects. So what is RSI? So RSI is repetitive strain injury. So repetitive strain injury. So as you repeat, so it is repetitive strain injury. So these affect the muscles and joints. As you type your keyboard, you might find that your finger starts to hit at those points and all that. So before we answer this one, what is ergonomics? So ergonomics is just the science of designing workplaces, tools and devices to fit human body and its movements. Like how is the chair made? How is the table made with respect to where the person shall be sitting? That is what we call ergonomics. So ergonomics is very, very important. Is very, very important in the aspect that it also improves what we call safety and comfort. Like for example, let's say if this is the computer, then there is no chair here, then someone has to be standing for them to type. They have to be standing for them to be typing like that. Then that simply means to say that is improper ergonomics. So ergonomics also promotes just safety overall. There's no way, let's say if the chair is made fixed like that, then it's very near to the computer. That would damage someone's eyes. So ergonomics is the science and of designing workplaces, tools and devices in order to fit the human body. How is the chair made? There's no way you can create a chair that someone has to constantly be sitting on. Then the chair is like this, then someone is sitting like that, then they are waking, they would sleep. So that is important as it promotes safety and comfort. Then we have technology addiction is. So technology, it is an addiction, so it has to do with a behavior. It is a behavioral risk. So addiction, this involves the excessive use affecting health and productivity. So someone is the whole day 23 hours. Someone throughout the 23 hours of the day, someone is playing games. So this is a behavioral risk. Then we have cyberbullying occurs. So remember what cyberbullying is. So cyberbullying is just the harassment in which someone is using digital platforms, such as we can have Facebook. Someone is being bullied, is being body shamed on Facebook, on WhatsApp and all that. So that is cyberbullying. So this is done online. Then we have our 72 doxing. So doxing, when someone doxes you, it means to say they have shared private information without your consent. So doxing is simply sharing private information without consent. Then we have e-waste refers to. So these are devices that are too old or phones which have been neglected. So E-waste is just odd electronics. So odd electronics could be phones, could be computers. Then we have E-waste, which is the electronic waste. It could contain what we call toxic metals. It could be metals such as lead, it could be mercury. So it contains toxic metals. It's not plastic, it's not water, it's not air. No, it is those materials that are used to make mostly computers. So that is basically what e-waste is. So recycling, on the other hand, reduces. So for this one, the best answer is recycling reduces pollution. So as we see, we have e-waste. It has these toxic metals, but if these are recycled, that simply means to say you are reducing pollution. Also cost, but the best answer is pollution in that regard. Then we have SEM, promotes. So what is SEM? So this is just sustainable electronic management. Sustainable electronic management. So sustainable, sustaining something, electronic management. So this one is just promotes what we call reducing e-waste. So the wasting of electronic materials by safely taking care of them. Then we have buying green means. So buying green simply means what we call buying substances that are eco-friendly, which means to say we are looking at choosing environmental safe products. You are choosing environmental safe product. So this simply means to say you are buying green simply means to say you are choosing materials that have less energy requirements or are energy efficient, meaning to say they use energy properly. So we have energy efficient and all that. Then 78, donating electronics. So these are general knowledge questions. So to donating electronics, it reuses them. So if you donate, let's say, to someone, that person will be able to use that device. Recycling electronics also reuses material. So to recycle is to reuse. Our AET, cloud storage, stores data remotely, meaning to say, when we say remotely, we simply mean to say data is stored on the internet servers, and can be accessed online. So you don't have to carry, let's say, your laptop. If you have another laptop somewhere, let's say you are in town A, you go to town B, then all you have to have there is another, let's say you leave the laptop there, you are on this laptop, you are able to access through cloud storage that information that you want. So that's on unit 2. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.